The product formed in the reaction is Me3CCH2OH on reacting with HBr. Here Me stands for methyl. Similarly, if you see ET in a competitive paper, it stands for ethyl. PH would stand for phenyl. And PR would stand for propyl, and so on. So basically we have three methyl groups attached to a carbon, CH2OH. So let's just try to write this reaction here. Carbon attached to three methyl groups is attached to a CH2 which is attached to OH. So you are reacting this compound with HBr. The reaction is a nucleophilic substitution reaction where ROH plus HBr OH minus gets substituted by Br minus to give you RBr plus H2O. So this is the concept. But we will be doing this reaction stepwise. So first we are removing this OH minus. CH2, and because we removed OH minus, this carbon has a plus charge. Now this carbon here is an example of primary carbocation. This carbon with a positive charge is directly attached only to one other carbon. Hence it's a primary carbocation. We know that tertiary carbocation is more stable than secondary as compared to a primary carbocation. So this carbocation is not stable. It undergoes some type of a shift so as to rearrange itself to form a more stable carbocation. If you see this carbon with a plus charge, next to it there is a carbon which is attached to three methyl groups. One methyl group along with its electron pair moves to this carbon. So you get this system was there. Now that methyl group moved here, giving this carbon a plus charge. If you are observing this carbocation, now this carbon is attached to three carbons directly, and hence it's a tertiary carbocation which is more stable. Now this was a nucleophilic substitution reaction. I already removed an OH minus. In its place now I have to add Br minus. The Br minus will go to this carbon which has a plus charge to give you this compound. So this is our answer here. If you check the answer with the solution which is given here, we have two methyl groups attached to a carbon which is attached to Br, which is also attached to CH2CH3. So our answer is D here. So whenever you see such type of a reaction where carbocation is involved, first you write the reactive intermediate, that is the carbocation. If it is unstable, see if any shift is possible. There can be either hydride shift or like we saw in this case, methyl shift, or there can be phenyl shift. Do this shift and see if you can get a more stable carbocation, then add the nucleophile.